Good morning, good afternoon, good evening, and welcome to another special edition of OpenShift TV. I am Chris Short, Principal Technical Marketing Manager here at Red Hat, and I am joined by a wonderful set of folks that are going to talk to us about AI and ML and the industrial edge. Again, I'm Chris Short. I'm going to hand it off to the one and only Stefan Bergstein. Stefan, please take it away. Introduce yourself.
Yeah, thank you. Thank you, Chris. So my name is Stefan Bergstein. I'm a solution architect working in Germany in the manufacturing space and working with obviously manufacturing customers on solutions, especially on cloud solutions, but also edge solutions. And a lot of interaction with customers, we came up with this edge blueprint, which we will share today. And with that, I will hand it over to Wolfram.
Hey there, my name is Wolfram Richter. I'm a colleague of Stefan, Chief Architect of Manufacturing for the German accounts. And well, we're both located in the snowy south of Germany. So good evening, everyone. And with that, I'll hand it over to Ricky.
Hello, I'm Ricky Noriega. I'm a Principal Software Engineer working at the Emerging Technologies Group at the Office of the CTO, working on edge computing topics. And I'm based in Madrid, same time zone as Germany, I guess. So I hope you enjoy the session.
Yeah, thank you, Ricky and Wolfram. So first, we will walk you through a couple of slides to introduce you to the problem area, what we are actually also solving with this blueprint. Then in the second section, Ricky will talk mainly around the blueprint concept and multi-cluster management. Second part, Wolfram will talk about GitOps and various aspects there. And I will close it then with the machine learning part of this section. So let's jump into the intro slides. Let me share my screen quickly.
And we will plan to interrupt each other frequently. So
yes, that was the first one. Yeah. Let me know if you can see my screen with a.
We most certainly can. Yes.
Slide. Good. Yeah. Thank you. So first of all, the domain. Let me talk a little bit about the domain because when talking about edge computing, it can be a lot of different things. And we are here in the industrial edge, which have, for example, telecommunication, manufacturing, energy, and many more. And especially when this blueprint, we have focus on industrial and manufacturing use cases around predictive maintenance, factory automation, augmented reality, visual inspection. And the resulting benefits are of, for example, reduced downtime and increased productivity. Because for the manufacturers, it's really important to have as little downtime as possible and also have quite a long life cycle of the assets. And not to forget about improved factory safety. But similar use cases also in the energy or benefits in the energy part, where we're going after reduced downtime and lower OPEX and CAPEX. And when we talk about manufacturing, we in Red Hat, we see it pretty broad. For example, everything what's a kind of provider of goods and the related services. Can be high value assets like an automotive, shipbuilding, trains, aerospace, and defense, for example, but also consumer goods like and industry parts, consumer goods, electronics, home appliance, but also industry things like power tools. And last not least, we look also at the process industry like chemical companies or pharmaceutical, for example. So and all this area, the edge computing is used and new use cases are applied, and we will showcase that here in a minute.
And with the blueprint we're showing today, just to mention this thing, if we're talking energy, right, even though we're demonstrating a concept around factories, you can replace basically a production line with a substation, and similar concepts would apply. So really this can be skinned to an energy industry blueprint as well.
Yeah, sure. And edge tiers. So a quick slide here about edge tiers. how we see it here at Red Hat. On the right-hand side, what's here named Enterprise Core with the core data center and regional data center. These are the typical data centers that we see in enterprises or on-premise, off-premise clouds. Today we will talk about, on one hand, these enterprise core, but also going to the far left, where we have the end user on-premise edge. For example, with edge servers or gateways where different sensors are connected, and also the infrastructure, for example, in the manufacturing plant. And in the middle, what is here named provider edge, these are service provider, telecommunication provider, which in that use case mainly ensuring the communication between the provider and core and the end user premises. We can dig down here a little bit into the end user premises edge, which we focus today. And we will see also that, or we see that our customers have here, obviously manufacturing execution systems for use cases, also addressing predictive maintenance, quality assurance. One challenging task here is also that there's different kind of technologies like OT, operational technologies in the plants, like SCADA systems or PLCs, and then also IT, a lot of IT, and then the challenge to bring these together for the use cases. And one other thing, what is here to highlight is that the firewall environment. So it's not new to any industry, but also here especially there's no inbound communication. Even within a factory, there are a lot of firewalls. Ensure that these plants and production lines are completely protected. And now jumping into the questions, and which we have discussed with the customer before we created the blueprint and the solution. And here 5 typical things which we see also addressed at the blueprint, like how can I achieve real-time transparency? So that getting the data collected to do then later on proper planning and optimization and the control of production. One key point is another key point is the second row here, where customer asks us, hey, how can we do a good configuration management across for applications that are really in one piece is eventually on the core data center, regional data center, and other parts of the applications on the manufacturing plant, and how to do a configuration management across plants and across these multi-tier applications. And you see then later on the GitOps approach that we have here in the blueprint. Third area also, how do I benefit from machine learning? And one use case really around quality and production. So the basic idea to say, hey, technology is there, I can train my models in the core data center in the cloud, and then deploy machine learning models into the edge on a regular basis. This fourth line, after collecting all this data, also connected to the first item, collecting a lot of data, storing data in a data lake, so that I can do the proper analytics for all things going in the manufacturing shop floor. And the speed of software development and also software releases is also key aspects, because traditionally there are long periods or long time until newer functionality which is developed then really going out of into the production line. And the basic idea, what we know today from internet application, you code, you deploy multiple times a day or even in an hour. That's not really already in the manufacturing space or in the industry space. And the challenge we are addressing here is from the core data center into the manufacturing edge, so that the software life cycles and releases can be extremely shortened. So that's are the challenges that we are addressing here with this point. And yeah, Wolfram, you had additional points.
Especially the last thing is really usually a difficult thing, because as you already mentioned, right, there's firewalls. So every plant is really firewalled off. Usually there's no easy way for a corporate headquarter to just sort of drill into a plant and say, install this new thing. So we need to find some other way where sort of the plant actually pulls in the new configuration and applies it. So that is sort of one of the challenges that was really unique to the manufacturing edge.
Yeah, and with that, I would like to hand it over to Ricky, and Ricky will walk us really through the first part around the blueprints and deploying clusters in the remote location with Red Hat Advanced Cluster Management. So Ricky, take it away from here.
Yeah, let me share my screen. Can you see my screen?
Yep.
All right. I'm going to talk about what this blueprint concept is and why we are promoting this. And I'm not going to give like a deep explanation of what ACM is. I know there was a session with Josh Packer, the tech lead of Red Hat Advanced Cluster Manager, but I'm going to give how we are a brief explanation of how we are using in this solution. So to give a little bit of context, like we've been hearing a lot about Red Hat's strategy on hybrid cloud and managing clusters on-prem or on public clouds. But the way we consider these clusters is that they are pretty important for the user or the administrator, right? So we have in this multi-cluster architecture, we have a few Snowflake clusters with different purposes, like for example, development, staging, production, or where they are located and things like this. But in edge computing, the picture looks a little bit different. In an edge computing network, it tends to have hundreds or even thousands of identical clusters. So the key here is reproducibility. Rebuilding and adding a new cluster should produce the exact same result every time. So it looks like we are facing this pets versus cattle dilemma again, but instead of at the application level, now at the cluster level. Having this in mind, what we have adopted or promoting, what we are promoting is this blueprint pattern. What is a blueprint? It's basically a recipe that contains the definition of the whole edge computing stack, from the infrastructure up to the applications running on top, going through the characteristics of the cluster, versions of Kubernetes, OpenShift, etc. And it should be all described in a declarative manner using Kubernetes manifests. So since we have mentioned before, one of the main qualities in edge computing, or the most important qualities in edge computing, is reproducibility. Having such a description of the whole stack is very beneficial, especially when you mix it with something like GitOps, right? So let's picture you have a catalog of blueprints that can be deployed in a reproducible manner and that can fulfill different use cases. For example, people could use those blueprints, improve them, create a community around them. It looks like it's a cool idea. So this blueprint pattern started in Acrano. Acrano is a project of the Linux Foundation Edge. It was started by AT&T with their Airship project, and Red Hat started their own project to basically to avoid that it becomes like there is only one way to do things, right? So with our project, which is called the K&I blueprint family, Kubernetes native infrastructure family. We are demonstrating that we can do the same kind of things, but with Red Hat technologies. And I will show you now how the repo is structured and everything, but first, as a general description, the way that we have structured these blueprints is just one implementation. So it doesn't mean that everyone has to do this structure or anything. You know, it's basically describing infrastructure, the cluster, and the applications running on top in a declarative manner. Then you can deploy many times the same thing. So in our case, we have 3 layers. We have the base layer that contains the common configuration for all the clusters in your edge computing network. We have the profile layer, which is contains the configuration for a specific purpose, right? So it could be a footprint, so a specific configuration for AWS, bare metal, VMware, or even for a purpose. If you have a set of clusters that you want to have with a certain component for development, like code-ready containers, you can create a specific profile for that. And then the last layer, the top layer, would be the site layer. A site is basically one cluster, and that folder contains the configuration for that specific site, for that specific cluster. Like we would change the cluster name, the domain, credentials, things like this. For this Akraino project, we created a tool called K9CTL. And I want to emphasize really hard that this is not a wrapper of the OpenShift installer. It is just a tool to help us render all these manifests, all these, the blueprint basically. So you can deploy a blueprint without K9CTL, but we are using it in this case just to automate some steps. For day one, it would be you download the binaries that you need, like OpenShift installer, OC, etc., customize in this case. And then we would render the manifests located in the blueprint with customize. We generate the manifest in a way that can be passed to OpenShift installer. And then we use OpenShift installer binary to deploy. In this session, we will use, we will deploy on a public cloud because it's easier, but we have tested it with even bare metal IPI, so we have created a site for a specific, a site configuration for a specific cluster in a bare metal cluster, and it works. The concept is the same. And once you use OpenShift installer, then and the cluster is deployed, then you apply basically OC apply -k, right? So basically you apply the manifest on the second stage, let's say, on the day 2 operations. I will show you now the repo. Let me get up here. So Red Hat Edge Computing. So we have created this organization in GitHub, Red Hat Edge Computing, where we locate the blueprints. First of all, the documentation, everyone can fork these repos and play with the blueprint, use it and improve it, test it, whatever. So it's up to the users to take it and play with it. It's all described in this documentation, how to deploy it. We have a little bit of introduction here. And basically what you have to do is fork the repos that I'm gonna explain now, which are basically four repos. The Blueprint Management Hub that describes the corporate hub cluster, the Blueprint Industrial Edge, which is a description of the edge sites, and then a couple of application repos that Wolfram and Stefan will explain later. But it's basically forking. You change a couple of parameters or variables. You create repos, Quay repos to store some images, and then you can deploy and play with it. Let me explain just one blueprint because the structure is the same. I'm going to explain here the management hub, for example. So as I said before, we have these three layers, right? The base, profiles, and sites. If we go to sites, well, we have, since in this solution, there's only one cluster with this recipe. The recipe is the management hub, right? So we have only one cluster in our network that has these characteristics. So every layer will have these four directories. The first two are meant to be rendered for day one operations. So the first one, basically, if you apply customize to this folder, you will get a full-fledged install config.yaml. And the cluster mods is a stage where when you generate the manifest out of the OpenShift installer, and then you want to perform some modification like patch, for example, the ingress replicas, or in a bare metal environment, it's very typical to disable DHCP on certain interfaces. So, deployment doesn't take too long. So you can do that in the cluster mods stage. Once you have the cluster deployed, cluster add-ons are basically operators that you need to run your workloads, and the 03 services folder are the services that you are gonna run. If we go to base and cluster add-ons, we can see many components here. So we deploy Advanced Cluster Manager, we pre-provision edge computing clusters, we deploy Argo CD, OpenShift pipelines, Open Data Hub, and many other components. So with this in mind, that it's basically a description of a cluster, or it's a recipe to deploy the same kind of clusters again and again, we have developed these two repos, the Management Hub and the Industrial Edge. And for the Industrial Edge, which is the clusters running on a factory, we have developed three different sites. One running on GCP, one running on AWS. These are basically, I know that these are not the typical footprint that manufacturing company will have in the factories, but for testing purposes is really convenient. And we have this MVP Edge Industrial, which is our bare metal cluster. For this session, we have already deployed the hub and the GCP one, and I'm gonna deploy this one, which is called which is running on AWS. So let me go back to the terminal. Okay, I have three TMUX tabs here, one for the hub, which, as you can see, it's a 6 nodes cluster. So in theory, it should be like a big cluster. The edge cluster running on GCP, it's a 3 nodes footprint, which are, they take the master and the worker role. And what I'm gonna do here is explain the steps to deploy our second edge site, which is the AWS. So first of all, it's all described in the documentation. And if you have any question, please stop me and we can talk about this. But first of all, we need to download these binaries that we will need, and we'll have specific versions. So with KNICTL, we have this fetch requirements command. It points to github.com. Monkey the user is the organization that we are using, and it's basically a fork of the repos that I just explained. Blueprint Industrial Edge. sites and staging edge. So this is the AWS. So we fetch requirements, and it's basically downloading kubectl, OC, OpenShift installer binary. I will show you now where they are located. It's pulling the OpenShift install binary. And, you know, these are all steps that you can do manually. So for example, these binaries are located in the profile layer, and these requirements.yaml is basically URLs to pull the binaries, right? So, you know, you can go do a wget this URL and you will get the binaries. We locate all this in under home KNI, and we have the staging edge dev cluster. So it has two folders right now: the site, which is basically a clone of the blueprint, and the requirements. So in the requirements, we have kubectl, OC, OpenShift install, customize. Basically, we only use OpenShift install and customize under, you know, behind the scenes. And the site contains the structure that I explained before. It's just the site configuration. So now we perform another step, which is prepare manifest. Now we don't point at the URL, we just give the name of the site. And what it does is it downloads the blueprint, so the profile and the base, and it applies customize. If you don't know customize, it's a tool from the Kubernetes ecosystem that allows you to create overlays on top of Kubernetes manifests. And it's not like only a YAML parser, but it also understands CRDs and basically Kubernetes objects. And if we check again what's here, we have a bunch of other stuff. We have downloaded the blueprint, and we have rendered all the manifest. And if you see here, the final manifest, it's exactly what you would do when you use the OpenShift installer to generate the manifests. I don't know why I have this OpenShift install log and OpenShift. Maybe it's from a previous installation. So I'm gonna remove the folder, do these two steps again. And then the last step would be basically to run OpenShift installer, install, create cluster, pointing at this final manifest. So this folder is something that the OpenShift installer can understand, and the installation would start. Maybe I can just remove this to OpenShift install. I think it should work. Now, no, okay. Let me demo effect. It's we do the same. It's fetch requirements, and while this is pulling the binaries, just one last step before I hand it off to Wolfram. I wanted to show the cluster, the Advanced Cluster Manager, ACM. As I said, we have already deployed two clusters, the hub and one factory site, which is this staging GCP. The way that we have structured this is that we have the registration manifest inside the blueprint. So whenever you apply, you deploy one factory site, there is there will be a self-registration mechanism to import the cluster automatically into ACM, and then all the components that are supposed to be running on the factory will get pulled. So there is a subscription and a channel, and it will deploy Argo CD, and and the rest is all GitOps that we in this channel we have talked about a lot.
So Ricky, a quick question. Does that mean after the initial install that's kicked off via the command line, basically after that, the whole configuration is controlled through ACM, and I just have my whole desired state in Git, and sort of if I need to change something in the cluster configuration, I do that in the Git repo?
Yeah, we are going to change it for probably version 2, but right now, once the cluster is installed, what we do is apply the day2 manifest, which is basically the clusterlet. Clusterlet is the agent of ACM. Then once this is deployed, it will, all the party will start and all the components will get deployed and everything. So yeah, it will reflect the state of our repo.
Cool.
Sorry, let me go back to the terminal. We do the same, prepare manifests. And we create the cluster. Like, it's very basic, right? It's OpenShift install, create cluster, pointing at this final manifest, which is our blueprint, our blueprint in a rendered form that OpenShift install binary can understand. And yeah, now it's deploying. This will take like half an hour, so probably we can continue with the Manuela part.
Yeah, can we put in the Jeopardy jingle now, where we sort of start waiting for stuff? Or should we context switch now while this is running, and then we can revisit it later?
Yeah, that's fine.
Cool.
Let's show some goodies from Manuela.
So before I start confusing the audience, are there any questions pending that we might want to address right now?
Not yet, but audience, feel free to ask away.
Right. So whenever something comes up or is interesting, or we should drill deeper into some aspects, just fire away with questions, and we'll try to address